Students, welcome to the next video of Theory of Machines. In today's lecture, we'll continue our discussion on analysis of clutch. Today's discussion will be very much relevant to your GATE exams, and at the end of the lecture, we'll also solve a numerical problem. So let us consider a clutch assembly where there is a driven shaft and there is a driver shaft, and both are connected with a clutch. P be the power that is to be transmitted from the driver shaft to the driven shaft, and T be the torque to be transmitted or torque of the driver shaft. T2 is the torque on the driven shaft, and omega 1 is the angular velocity of the driven shaft, omega 2 is the angular velocity of the driven shaft. Similarly, I1 is the moment of inertia of the driver shaft and I2 is the moment of inertia of the driven shaft, and likewise alpha 1 and alpha 2, the angular acceleration of the driver shaft and driven shaft respectively, and also theta 1 and theta 2 is the angular displacement of the driver shaft and the driven shaft respectively. So as we know that the power transmitted is equal to 2 pi n1 t1 upon 60, and the torque is also equal to the product of moment of inertia and the angular acceleration. So here we have taken t1 as minus I1 into alpha 1. Why negative sign? Because there will be deceleration in the driver shaft. The driver shaft will be having reduced speed. Its speed of rotation will be reduced as it will be engaging with the driven shaft. Next, from here we can write alpha 1 is equal to minus T1 upon I1. Now alpha 1 is also equal to, in terms of angular displacement, is equal to d square theta 1 divided by dt square is equal to t1 upon I1. Now integrating this to get the angular velocity, we have d theta 1 upon dt is equal to minus t1 upon I1 into t plus c. It's a constant of integration. Now applying the boundary condition, as at t is equal to 0, d theta 1 upon dt is nothing but the angular velocity of the driving shaft, that is omega 1. So we can write this equation as d theta 1 upon dt is equal to minus t1 upon I1 t plus omega 1. So this will be our equation number 1. Similarly, for the driven shaft, we can write t2 is nothing but I2 alpha 2. Here it is positive because the speed of driver shaft will be speed of the driven shaft will be increasing and it will be accelerating as it is engaged with the driving shaft. Similarly, we can write alpha 2 will be equal to T2 upon I2, and alpha 2 is nothing but angular acceleration. So d2 theta 2 upon dt2 is equal to T2 upon I2. Similarly, as previously done, integrating this, we have d theta 2 upon dt is equal to T2 upon I2 t plus c dash. C dash is the constant of integration. Again applying the boundary condition, at t is equal to 0, d theta 2 upon dt is nothing but the angular velocity of the driven shaft. So applying this to this equation, we have d theta 2 upon dt is equal to t2 upon I2 into t plus omega 2. So this is nothing but our equation number 2. Now, as the driven shaft is engaged with the driving shaft, initially there will be some slip due to the speed differential. But after some time t, both the driver shaft and the driven shaft will be having equal speeds. So let t be the time when the driver and the driven shaft speeds are equal. So at that time the torque transmitted will be same. So as the speeds will be equal, so we can write that d theta 1 by dt is equal to d theta 2 upon dt, which implies that from equation 1 and 2 we can write minus t1 upon I1 t plus omega 1 is equal to t2 upon I2 t plus omega 2. Now as t1 will be equal to t2 and we can write it equal to t, we can have from this equation, we have, after rewriting it, we have t is equal to omega 1 minus omega 2 I1 I2 divided by I1 plus I2 into t. This is nothing but the slipping time, or the time that is required for both the shaft to come to the same speed. So this is the time for which the slipping will be there between the two shafts. Now as there will be slipping, so there will be some energy loss. So let us find out what will be the energy loss. So the energy loss during slipping time or the energy loss in friction due to clutch slip is given by frictional torque into angle of slip. So that will be equal to T into theta 1 minus theta 2, where theta 1 minus theta 2 is the angle of slip. Theta 1 is the angular displacement of driver shaft and theta 2 is the angular displacement of driven shaft. So difference between them will be the slip or the angle of slip. So this is how we can find out the energy loss and the slipping time. These are the two very prominent questions asked in the GATE exam, especially on the slipping time. So now let us solve a numerical problem related to clutch. So let us take a problem. The problem is the external and internal radii of a friction clutch of disc type are 90 mm and 50 mm respectively. Both sides of the friction clutch are effective and coefficient of friction is equal to 0.25. The friction clutch is used to rotate a machine from a shaft which is rotating at a constant speed of 240 rpm. The moment of inertia of the rotating parts of the machine is 5.5 kg per meter square. The intensity of pressure is not to exceed 0.8 into 10 raised power 5 Newton per meter square. Assuming uniform wear, determine the time required for the machine to attain the full speed when the clutch is suddenly applied. Also determine the energy lost in slipping of the clutch. So we are given the following things. The external radius is 90 mm, internal radius is 50 mm, and as we are giving the both sides of the friction clutch are effective, so number of sides are 2, that is n is nothing but 2. Coefficient of friction is given as 0.25. The friction clutch is used to rotate the machine shaft, so constant speed and number of revolutions are given as 240 rpm. Moment of inertia is also given as 5.5 kg per meter square. Now the pressure is not to exceed by 0.8 into 10 raised power 5. So this is nothing but the maximum pressure given. As we know from wear theory, pressure into radius is constant. That means the pressure is inversely proportional to the radius. So this maximum pressure will be found at the inner radius, and we have to apply the uniform wear theory. So we have to find the time required for a machine to attain the full speed. That means we have to find time required for the machine to attain full speed of 240 rpm and the energy loss during clutch slip. So time required for the machine to attain the full speed. So the driving shaft is rotating at a constant speed, whereas the machine is at rest for now. But when the clutch is engaged, the machine will attain the full speed not immediately but after some time. That means after some slip. So let us take this time as t seconds. That means the machine will attain the full speed after t seconds. So first let us find out the axial load or the axial force and the total frictional torque for uniform wear. So from uniform wear we have P into R is equal to constant, and we just discussed. So we will have P max at the inner radius. So we can find out the constant C. So the pressure will be maximum at the inner radius. So P max into R2 will be equal to C. So from here we get C as 4000. Next, for the axial load we have W is equal to 2 pi C into R1 minus R2. This we discussed in the previous video. So from here we can find out the axial load that should be applied to engage both the shafts. That is nothing but 105.31 Newton. Frictional torque, again this we discussed in the previous video. We derived this equation as the frictional torque is equal to T is equal to 2 times, this is N, as both the frictional surface are active. So this is N, and mu W upon 2 into R1 plus R2. R1 plus R2 upon 2 was nothing but Rm. So from this we can find out the frictional torque to be 35.186 Newton meter. Further, we should find the angular acceleration when the total torque is 35.186. So for that we know T is equal to I alpha. So T is equal to I alpha. So from here we can find out the alpha as 6.397 radian per second square. Fine. Now the machine starts from rest. So after some time the final angular velocity of the machine will be corresponding to the angular speed of the shaft, that is 240 rpm. So final angular velocity will be equal to 2 pi n by 60. So we have final angular velocity of the machine omega as 8 pi radian per second. Now initial angular velocity of the machine was 0. So by applying the equation, we can find the time. Using the equation, omega is equal to omega 0 plus alpha t. We get time t is equal to 3.928 seconds. We could have found out this time t by using the equation that we derived today. But this is another way to do. So we have omega is equal to omega 0 plus alpha t. So from here we can find out the time which is required for the machine to attain the full speed. So this is nothing but 3.928 seconds. Next we need to find out the energy loss. So energy lost in slipping of the clutch. Driving shaft is rotating at the uniform speed of 240 rpm. So the angular speed will be 8 pi radian per second as we have already calculated. Whereas the machine starts from rest and attains the full speed in time 3.928 seconds, that is t seconds. Now let us find the angles turned by the driving shaft and the machine in the time t seconds. So we are finding out the angular displacement theta. So that can be done by using theta 1 will be equal to omega t, which is nothing but 8 pi into 3.98 second, that is 98.72 radian per second. This is a simple equation of angular velocity and angular displacement. So similarly, we can find out the angle turned by the machine. Angle turned by the machine can be obtained by theta is equal to omega 0 t plus half alpha t square. These are the basic equations of motion. Theta 2 will be omega 0 t plus half alpha t square. Omega 0 is 0 and half alpha, and this is, we have theta 2 is 49.35 seconds. So now from the equation, energy loss is equal to T into angle of slip. Angle of slip is nothing but theta 1 minus theta 2. So we can find out the energy loss in friction due to clutch slip as shown here. So this is nothing but 1737.13 Newton meter. So this is how you can find out the energy loss and the time required to attain the full speed. In case of, so I hope you will solve more questions from your textbook, and in case of any problems, please contact me. Thank you.